So now I'm going to talk about the task 3. So task 3, basically, I want you to look at the worksheet, and then you just need to fill out this worksheet. But there's gonna be a lot of calculation. Okay. So I'm gonna go over each of them. So the first, you need to fill out the calculated acetic acid concentration. This one, most of you done already, because you need to know this concentration to make solution F, okay, in task 4. Okay? So this A should be, everybody should have 0.7, and then the B, C, so on. You diluted 1/10 from the previous one, so this one should be 0.07. Oh no, the B should be 0.07, and this one is 1/10 of the B. Okay? The next one is the observed pH. This is just the data from the task 2, task 3, so you don't have to do the calculation. Okay? And the next one is the observed percent ionization. Okay? So the percent ionization, you can find the equation on page 69, which is H3O plus divided by HA, so which is acetic acid concentration times 100%. Okay, so that's the equation. So the third one, so you have to find the observed percent ionization, which means that this H3O plus you will calculate from the observed pH and then plug it in, and this acetic acid concentration is from the first one, that times 100%. Okay, I will show you how to do it using solution A. Okay, so let's say observed pH for the solution A is, I'm just making that up, so let's say 3.0. Okay, then pH equals 3.0, which means minus log of H3O plus. Okay. And then you solve for H3O plus, which is 10 to the minus 3.0. Okay, you get the number. Then now you can calculate the percent observed ionization for solution A. So this answer is going to go to the top, okay? And then divided by acetic acid concentration, which is 0.7, that times 100%. Okay? So that's percent observed ionization. Okay. Next, I want you to look at the worksheet and say, now you have to calculate the theoretical pH. So the theoretical pH, probably most of you already learned in the lecture. Okay? So the theoretical pH, you can predict the pH based on the initial concentration of the acetic acid. So I will use the solution A. Okay? Solution A, again, acetic acid is 0.7 molar. Okay? Since acetic acid is the weak acid, it will dissociate. Okay? So you have to use the dissociation to calculate the theoretical pH, which is the acetic acid with water that becomes conjugate base and H3O plus. Okay? And then you have to use the ice table. So the initial concentration of acetic acid is 0.7. First, here is 0. And change, that's the one we don't know. So at the end, 0.7 minus x plus x plus x. Okay? So that we use the Ka for the acetic acid which is I believe the 1.5 times 10 to the minus 1.8 times 10 to the minus 5, or you look it up, okay? For that, this one is for the acetic acid. That's equal to the x squared 0.7 minus x. Okay? For the solution A through C, you can use the simple version, which is you can ignore this x, okay, and then calculate the x. So, which means that x squared, the simply is gonna be 0.7 Ka, and then so for x. Okay, that's equal to H3O plus. Okay, and the pH, of course, minus log of H3O plus. So that means minus log of x. Okay, so that's your theoretical pH. Okay, but solution D and solution E, since the concentration, the initial concentration of acetic acid is small, you cannot use this simple version. You have to use a quadratic formula to calculate the x. Okay? If you have any question, ask your instructor for this one.